So chapter 21 is titled Principles of Chromatography and Mass Spectrometry. This is the chapter 21 and chapter 22 go together. 22 just goes in more detail with chromatography. So the idea of chromatography is really important in not just chemistry but in science. It is widely utilized for anyone who is thinking that maybe someday they want to work in a lab. One of the instruments that I can promise you that you will be using will be some type of chromatography. So in chapter 21, I'm going to hit the principles, the background a lot harder. Mass spec, we're going to discuss, that's the mass spectrometry. We're going to discuss that, but you also will learn some about that in organic chemistry. The direction that we're looking at mass spec is more what is the instrument, how does it work, less on once you use the instrument and get results, what do you do with that? That's what you're going to learn more in organic. With chromatography in chapter 21, like I said, it's really going to be the background, and that's going to be the important stuff right now. So that way, when you go on to upper level classes and they discuss chromatography or you're given results, you have an idea of what's going on. Chapter 22 goes in more detail on the two most common type of instrumental chromatographies, which is gas chromatography and liquid chromatography. And so chapter 22, we are hitting just the highlights on that. But chapter 21, for all of the chromatography, we're going through the whole shebang. So background on chromatography. What the heck is it? Well, IUPAC, which is that group of people, that's the international chemistry people, basically, have defined chromatography as a physical method of separation in which the components to be separated are distributed between two phases, one of which is stationary, the stationary phase, and the other, the mobile phase, moves in a definite direction. So, depending on your experience in lab before now, if you took Gen Chem 2 at St. Charles Community College when the labs were on campus, you have done TLC, thin layer chromatography. You took these little white rectangles, they're glass with some stuff sprayed on it, some capillary tubes, dipped them in a liquid, made little dots on it, drew some lines with your pencil, stuck it in a chamber, and then let the liquid run up, and then saw some dots. That is chromatography. Thin layer chromatography, TLC. The C is for chromatography. So in that's I think to me, especially that's something you've done, the easiest way to think about chromatography because it's just right in front of your eyes. You can see all of the pieces. So in that situation, the stationary phase was the white sprayed stuff on the little rectangle. Okay, it never moved. That was just the surface on which the stuff happened. The mobile phase would have been the liquid that was at the bottom of the beaker that slowly rose up. The dots that you put on that was your sample. That was the substance you were trying to separate. And so when this happens, we're going to talk through the different types of chromatography, but with thin layer chromatography anyway, the reason why a mixture, one dot of a little mixture of a chemical will separate into its components as the mobile phase moves past it. And in TLC, it's all because of the intermolecular forces. The stationary phase will be, some version of polar or nonpolar somewhere on that spectrum. And the mobile phase will be a different version, somewhere on the spectrum of polar and nonpolar. And the components in the mixture will be more attracted to one than the other, but maybe not perfectly. So as the mobile phase, the liquid moves in the TLC example, moves up the plate, the stationary phase, components of the mixture, the molecules within the mixture that are more attracted to that are going to slowly move up the plate as well, just like the mobile phase. The components in the mixture that are not attracted to the mobile phase but are more attracted to the stationary phase will either stay where they're at or move much more slowly. And again, there's a spectrum. So it could be that, there are three components and they separate. So if this is my TLC plate and this is my starting point, and here's my dot of my chemical. At the end, if there's three things, we should see, if we designed the experiment correctly, three different dots. So the one dot became three dots. And we'll notice that in that example, the red would be gone at the end because that has been broken into those three components. None of those three dots stayed on that exact bottom point. The red line at the top, right there, is where the mobile phase stopped. That's when we took it out of the beaker, so the liquid stopped moving. None of the components in this example were all the way up there either. They were all somewhere in between because they were more attracted to either the stationary phase or the mobile phase than the other, but still attracted to both in some way. And so it was just that differences between them. So chromatography, we're separating a mixture. And in chromatography, if we're separating a mixture, so we're not doing a chemical reaction, we're separating a mixture, there has to be a stationary phase and a mobile phase, and that will be important as we move forward. So in chromatography, there's an equilibrium situation happening between that stationary phase, the one that doesn't move, and the mobile phase. Okay, so if we think about chromatography in a way that we don't do in organic chemistry at St. Charles Community College, but is done often in organic chemistry, think of like a burette. Oh, yep, that's a burette. Sure it is. There's the stopcock. Yep, this is glorious. And let's pretend like the burette, we filled it with, um, let's go with sand. So this is all sand, and let's say that it's completely solid, completely filled. Okay. And then I've got, I don't know, cyclohexane that is going to be my mobile phase that I'm going to pour in the top of the burette. But before I do that, I'm going to put my sample, my chemical that I want to test, right at the top. So instead of thin layer chromatography, this is another way to think about chromatography. In this example, the sand, the purple stuff, is my stationary phase. The cyclohexane that I'm going to pour in from the top is my mobile phase. And my sample would be at the top. And as that green sample moves down, remember it's a mixture, so it's going to break up into its components. It's going to separate just like it will in TLC. But what's happening is there's an opening at the bottom down here. So the liquid is draining out the bottom. And so you would just be constantly getting samples, in your beaker and your Erlenmeyer flask, collecting samples. And then the different components would come out at different times. Okay. So that's what this picture is trying to show. Picture number 1 would be like time 0. Picture number 2 would be like, I don't know, 2 minutes into it. Picture number 3 would be like 5 minutes into it. And then picture number 4 is like 10 minutes into it. These are arbitrary times, but it's the same thing, just over time. So the different shapes, I see some squares, some circles, and some triangles. That was a mixture that had 3 different chemicals in it. And so we can see by the end that each of the 3 chemicals separate out, just like they do in TLC. But what's different with this type of column chromatography is that we're measuring them at the end. And then we have to do some sort of, we're collecting them at the end, and then we have to do some sort of measurement at the end to figure out what's going on. So the equilibrium is that the relationship between the molecule, the compound, the component, in this example, there's 3 components, the triangles, the squares, and the circles. So between the component and its relationship between the stationary phase and the mobile phase. Okay. And so these molecules move at different rates based on that equilibrium situation going on. So I've already said this, but again, stationary phase doesn't move. The mobile phase does move. So the 2 examples I've given so far, the stationary phase was either the sand that's inside the like inside the burette, or the white stuff that was sprayed on the surface of a piece of glass. So it was a solid. And then the mobile phase in both of these examples has been a liquid. Okay. So in the example I gave you with the burette, the column, which is the burette, the glass container, the container it's in, is packed with the stationary phase. And the mobile phase is constantly moving through it because we have to constantly be pouring more liquid if we're pouring it from the top, or when we did the TLC, it was constantly moving up from the bottom. There was extra mobile phase. And then our chemical will be added and then allow the mobile phase to move through it. The mobile phase, the solvent, is constantly being added, and depending on what it's more attracted to, it either moves quicker or slower. So here's another picture, but this one's a little bit more accurate than the shapes because these bands, so this is compound A and compound B. So our mixture has 2 things. So our mixture has 2 things at the beginning. They're just this solid dark blue line. But as time moves on, we start to see, in this case, we see two different colors. In real life, you wouldn't visibly probably be able to see this unless the compounds themselves have a bright color, but we can see them starting to separate. And then they will emerge from the bottom of the column after different amounts of time. And it does take a specific, like the mobile phase that we're adding, we're constantly pouring the solvent, the mobile phase on the top of it, and then we'd be collecting it. So again, think of this container like a burette, um, as just something, that's how we can imagine this. So some terminology. The eluent is the fluid that's entering the column. So like the mobile phase that we're pouring in the top constantly. And the eluate is what comes out the bottom. Now that is a mixture of potentially the mobile phase and the sample. Okay. And so when we do this, this is called elution. We pour the mobile phase on the top and it helps separate the mixture and then it comes out the bottom. So it's elution when we do this. So we're going to pause here, and then the next video is going to go through the 5 different types of chromatography, getting in more detail on stationary and mobile phases.